So hello everyone. In this particular video, we are going to see that why the output of Jfet is 180-degree out of phase with respect to input. Okay. So for this, I'm making use of a voltage divider bias technique. Okay. Total there are three techniques, that is fixed bias, self bias, and voltage divider bias technique. And as I had explained in my post, that voltage divider bias technique is most preferable for biasing transistors. Okay, and reason I had explained in my post. So if you want to uh, like see, or basically if you want to understand that why voltage divider bias is most preferable as compared to other three techniques of biasing, then please do visit my post. The link of my post I had shared in my in the description box of this video. Okay, so let's start with this particular video. So our question was why the output of Jfet is 180-degree uh, out of phase with respect to input. Okay, so for that we have to revise some of the concepts where I had explained that concepts in my last videos, or maybe in my uh, posts in my last post. Okay, so during revision we uh, basically in last post or in my last video we saw that the input of Jfet, that is VGS. Even now you can consider V in as VGS, since G refers to this, since this is a gate terminal and this is a source terminal. Okay, so the input of Jfet was directly proportional to ID square, that means output current. Okay, so this was the relation we concluded in last post, and that's why Jfet is known as Jfet is known as voltage control current source. Okay, since the input voltage was controlling this output current, that why Jfet was known as voltage control current source. Okay, so to understand this phenomena, we will divide this into two cases, that is case 1 and case 2. So consider, now we will consider first case 1. So this is a case 1. Okay, and we are considering that the VGS, okay, the VGS, the input voltage is increasing. Okay, that means what I want to say is the input voltage we had applied is sinusoidal, that means it is AC in nature. So we are right now we are considering this positive half. Okay, that means our I am trying to analyze this particular part. Okay, as you can see. Okay, and let's say our VGS, or basically VG, is set to -2 volt by biasing. Okay, this is achieved by biasing. This is achieved by biasing of Jfet. Okay, so yeah, it is -2 volts, for example, and let's say if V in is increasing. Okay, if V in is increasing, that means VGS is still negative. Okay, that means VGS is still negative, but our VGS is trying, I mean, it is tending towards 0 volts. I can say that. Okay, why? Because see, if it is -2 volts, when I add, let's say this is zero point 0.5 volts, zero point 0.5 volts, so -2 plus 0.5 volts, so -2 volts plus 0.5 volts. What is the answer? Yeah, the answer would be, sorry, the answer would be -1.5, right? So it is tending towards 0. Earlier our voltage was -2 volts, which we had achieved by biasing, but now, since due to introduction of this positive half cycle of sinusoidal wave, it is -1.5 volts, right? So I can say that my VGS is tending towards 0. That means my VGS has increased. Okay, obviously -2 volt is less than -1.5 volt, and -1.5 volt is greater than -2 volts. Okay, that's why I can say that VGS has increased. Okay, so if VGS has increased, that means uh, if VGS has increased, that means my current has also increased, since it is ID square. VGS is directly proportional to ID square. That means my current has also increased. Good. So consider this as case 1, sorry, as equation 1, or basically just think it as a logic, or basically remember it, because now I will be explaining you KVL part. Okay, when we apply KVL to this particular loop, as you can see over here, the drain source terminal, when we apply KVL to this drain source terminal, so what we get is, I will zoom out so that you can understand it in better way. Yeah. So see, when I apply KVL, so VDD VDD minus IDRD, that means voltage drop across the drain resistor, then minus VDS, okay, this is the output, and minus IDRS, that is voltage drop across source resistance. Good. So when we simplify it further, so we get output voltage is equals to supply voltage, that is VDD, minus voltage drop across these two resistance. Okay, good. Okay, so we got this particular equation. Nice. Now we will come back to this case 1. Okay, so what we had learned in this case 1 was, or basically what we had analyzed in this case 1 was, uh, when VGS increases, ID, sorry, oh, what happened? Okay, no problem. When VGS increases, ID also increased. Okay, when VGS increases, ID also increased. Now look at this equation. If ID increases, that means this whole bracket, I mean, whatever the equation or whatever the numbers would be, it would get increased by certain factor since our ID is increasing. Okay, since our ID is increasing, that means the whole whatever the number that may be, it will increase. Okay, let's say VD is 9 volts, for example, and let's say the whole number, I mean this ID into RD plus RS, let's say it is 5 volts for now. For now it is 5 volts. Okay, so what would be your answer? Your answer would be 4 volts. Okay, that means your VDS is equals to 4 volt. I'm trying to uh, help you out with this example so that you can understand it in much better way. Okay, so in case 1 we are getting VDS is equals to 4 volts. Good. What that means is that this, if ID increases, that means your output voltage decreases, that is drain source voltage decreases. Okay, now we will analyze case 2. Okay, let me use some different color. Okay, so case 2 I am writing over here. Right now we are analyzing case 2. So let's say uh, yeah, so let's say our VGS, which was set to minus 2 volts. Okay, now we are talking about this negative cycle, okay, this particular negative cycle. Earlier our VGS was minus 2 volts. Now let's say since due to introduction of this negative sine wave, okay, our VGS become, let's say the value of sine wave is minus zero point 0.5 volts. Okay, so minus 2 minus 0.5 volts, which is equals to minus 2.5 volts. Okay, so basically our VGS is tending towards more negative or becoming more negative. Okay, so I can say that my VGS is decreasing now. Okay, if VGS is decreasing, that means ID is also decreasing since VGS was directly proportional to ID square. Okay, now see, if ID is decreasing, that means the whole factor, that means ID into RD plus RS, it will decrease. Okay, whatever the number would be, it will decrease. Since it will decrease, that means our VDS will increase. Okay, since this ID into RD plus RS will decrease, that means our VDS, the output voltage, will increase. Again, I will try to give one example again. So our VDD is fixed, let's say it is 9 volts minus. Now since our ID has decreased, so in this case I will consider this whole bracket, that means ID into RD plus RS, sorry, yeah, and since our ID decreases, that means I will consider the whole bracket, that means id into rd plus rs, as let's say 4 volts. So our answer would be 5 volts. So as you can see, when the VGS, or basically the input voltage, decreases, our output voltage increases. Okay, and similarly in case 1, when our VGS, that means our input voltage, was increasing, this particular voltage, input voltage, was increasing, then the output voltage was decreasing, and here the output voltage is increasing. Okay, that's why we are getting 180-degree phase shift. See, I will try to explain you this concept with the help of animation which I had created, so that your concept would be very much clear. Okay, so I will start the animation videos. Okay, I'll just take this out. Okay, so I'm starting this. So as you can see, if our V in is increasing, then our V out is decreasing. See, and this is the internal structure. And as our V in is decreasing, see, our V out is increasing. Okay, this I tried to explain with the help of internal structure, and here I tried to explain with the help of this equation. Okay, so I hope you understood this concept. If you like the video, then please do like, share and subscribe my channel. Thank you. And also please do subscribe my website, where I am explaining this concept in much detailed way. Plus I am also taking some basic projects which will help the engineers to cope up, to basically boost up their concept. Okay, so once again, thank you.